So we are doing question number 1. There is a second part to it. It says construct a 95% confidence interval about mu1 minus mu2. The differences of mean, right? So we already tested the first part. So here on your notes are the instructions. When we have two independent samples and we need to calculate the confidence interval for mean differences, you need to use two sample t interval. Okay, so all the information is given to you. You need to use your calculator. Go to stat, go to test, and it's we have two sample t interval. Remember, whenever you're talking about mean, you need to look at t intervals, and we are given with stats in this table. Okay, press enter. X1 bar, the sample mean of the first sample is 15.3. That's correct. uh, Standard deviation is 3.2, N1 is 15. All this information because we just entered for the last question. Confidence level is 0.95 and the data is not pooled, right? So leave that as is. Calculate. So finally, the confidence interval for mu1 minus mu2 is negative 1.409 to 3.61. Okay, that's what they were asking in this question. Let's go back to our notes. Let's read question number 2. Researchers conducted a randomized double-blind study. So they gave us its randomized and double-blind to measure the effects of this drug they're talking about, on patient diagnosed with bipolar disorder. A total of 115 patients with a SSM14 diagnosis bipolar disorder were randomly divided into two groups. So they were divided into two groups. Group 1, N1 is 55, received 5 to 20 milligram per day of this medicine, while group 2, where N2 is 60, received a placebo. The effectiveness of drug was measured using Young Mania rating scale. Total score with net improvement score recorded. The results are present in the table. So what do we have? So there are two groups, experimental group and the control group, right? So when we have the two groups, and you can see they are divided just in two groups, right? Without any matched pair thing going on. So that tells me this is independent samples, not dependent samples, right? So you need to read the question and figure out that these are independent samples. So results are presented in the table. What is given? N1 is given to be 55, N2 is given to be 60. Mean X bar for the first group is given to be 14.8. For the second group, it's given to be 8.1. Sample standard deviation for the first group is given to be 12.5 and it's given 12.7 for the control group. Does the evidence suggest the experimental group experienced a larger mean improvement than the control group? So this sentence tells me that I need to test that mu1, this is group 1, this is group 2. So I'm going to say mu1 is is larger than mu2. That is our claim. We have to test that. If we have to test that, then null hypothesis is just going to be mu1 equal to mu2. We need to first verify the requirements. Okay, let's check the requirements. They said in the question that it's a randomized samples. So random samples is done, right? The sample size is N1 is more than 30 and N2 is also more than 30. So we do not need to check normality. And what else? This is an independent set, right? So it's just divided into two equal groups. So there is no dependency, there is no matched pair. So we have all the requirements satisfied, and I'm very sure that N1 is less than 5% of the population and N2 is less than 5% of the population. We can assume that population size. So we have all the requirements, right? If we have all the requirements and our data is independent and we are comparing means, that means you're using two sample t-test for this. Okay, so let's open our calculator, clear what we have before. Here is your data. So go to stat, go to test. Two sample t-test is at number 4 and the stats are given in this question. X1 is given to be 14.8. It is here. This is X1 bar. This is SX1 bar. This is X2 bar. This is SX2 bar. SX2. So standard deviation is given to be 12.5. N1 is given to be 55. This is N1. Enter that. X2 bar is given to be 8.1. Standard deviation of the second group is given to be 12.7. And the number N2 is 60. And we are checking if mu1 is more than mu2. So you need to highlight the more than symbol. The data is not pooled. Press calculate. What do we notice? We notice t statistic, that means t naught is 2.849 and p value is equal to 0.002. That's what we notice. Go back to our question. Do we have level of significance, that is alpha? Alpha is equal to 0.01. That means if we compare, p-value is clearly less than alpha. So according to p-value approach, we are going to reject H naught, right? So let's check the t statistic approach also by drawing a t distribution. This is a right tail test because this is telling me that I have to do right tailed curve. So you need to draw a right tail. The whole alpha will go into the right side. That means this value here, the critical value which is dividing your thing is T alpha. Alpha is 0.01. And degrees of freedom. How do you check degrees of freedom? That is the smallest value of n1 minus 1 or n2 minus 1. n1 minus 1 is 51 minus 5. 55 minus 1, 54. So DF is minimum of 54 or 59. How did we get 59? 59 is 60 minus 1, right? So minimum of these two, that is your degrees of freedom. That is 54, right? So degrees of freedom is 54. So let's look into the Collin formula chart. T.01, so that means we are into this column here. And degrees of freedom is 54. So if the numbers are like, we don't have 54 here, right? Whichever is closer. 50 is more closer. So go there. So this is the number 2.403 and in the 0.01 column. So we're going to say this is 2.403, the T critical value. And our test statistic here is 2.849. It's going to be bigger than that. So test statistic is in the critical region or the rejection region. So using classical approach, we're going to say test statistic is in the critical region or rejection region. So the same result, reject H naught. Okay. So let's look at our question again. We are rejecting H naught, that means we will accept H1. If we reject H naught, means we are accepting H1. So what does that mean? There is sufficient evidence to support that. What will you write? Support. So here you need to write your claim. What is the claim? The claim is written exactly in the question. That is, does that says the experimental group experienced a larger improvement than the control group at the zero point 0.0 level of significance. So you need to start from here, sufficient evidence to support there. Okay, so write that down in your conclusion as your final statement. So this is the method for when we have two samples, they are independent of each other. In the exams, the hint is if both the n1 values are different, n values, that means it's not dependent, right? If it is matched pair, the n values have to be same. But if they're different, that gives you a clue that you have to run two sample t-test.